the smartest AI in the world. We're going to show you exactly how and why. And it really is remarkable to see the advancement of artificial intelligence, how quickly it is.
Not long ago, a team of researchers at MIT set out to explore something unusual. They introduced Grok, the artificial intelligence model developed by XAI, to a series of questions centered around one of the greatest mysteries in science, the Fermi Paradox. Put simply, it asks, if the universe is so vast, why haven't we found any clear evidence of other intelligent life? At first, the experiment appeared purely theoretical. The researchers simply wanted to see how an advanced AI, trained on nearly all publicly available human knowledge, would interpret the possibility of extraterrestrial civilizations. But when Grok generated its response, and parts of it were quietly shared among experts in SETI and astrobiology, the reaction was not excitement. It was discomfort. Something about the answer didn't feel like a discovery. It felt more like a warning. Before we go further, make sure to subscribe to the channel, because what comes next might completely change how you think about our place in the universe. So what exactly did Grok say? To understand that, we need to step back and revisit the question itself. A question no one has answered, yet no one can ignore. The Fermi Paradox remains one of the most enduring mysteries in modern science. It dates back to 1950, when physicist Enrico Fermi reportedly asked, during a casual discussion, if intelligent life is common in the universe, then where is everybody? This isn't just philosophical curiosity, it's grounded in numbers. The observable universe contains an estimated 2 trillion galaxies. Within our own Milky Way, there are somewhere between 100 and 400 billion stars, based on precise measurements from the European Space Agency's Gaia mission, which has mapped over 1.8 billion stars in remarkable detail. Planetary science has only strengthened the mystery. NASA's Kepler mission, which studied more than 150,000 stars between 2009 and 2018, revealed that Earth-sized planets in habitable zones are not rare. They may exist around at least 1 in 5 sun-like stars. Its successor, the TESS mission, continues to expand that data. Then there's time. The universe is about 13.8 billion years old, a figure derived from observations of the cosmic microwave background by the Planck satellite. By comparison, our solar system formed just 4.5 billion years ago. That gap matters. It suggests that other stars, planets, and potentially civilizations could have formed billions of years before Earth even existed. Statistically speaking, intelligent life shouldn't be unique. And yet after more than 6 decades of active searching, dating back to Frank Drake's Project Ozma in 1960, we've found nothing. No confirmed signals, no alien probes, no massive structures visible across space. Just silence. And that silence is the paradox. Over time, scientists have proposed many explanations. Some argue that intelligent life itself may be incredibly rare, as evolutionary biologist Ernst Mayr once suggested. Others believe civilizations tend to destroy themselves before reaching advanced technological stages, a concern often raised by physicists like Michio Kaku when discussing nuclear risk or climate collapse. Another possibility is that advanced civilizations deliberately stay quiet, a concept often referred to as the dark forest theory, popularized in science fiction but grounded in game theory. Or perhaps signals are already out there, but we simply don't recognize them. Each explanation leads to a different and often unsettling conclusion. And it's within this framework that the MIT experiment becomes important. This was not a simple question and answer test. The study was led by Dr. Priyamvada Chandrasekaran, a cognitive scientist focused on AI reasoning systems, alongside astrophysicist Dr. Julian Marsh from MIT's Kavli Institute for Astrophysics and Space Research. What made their approach different was the structure. Instead of asking Grok a single question, the researchers designed a multi-phase dialogue, an ongoing exchange where the AI was pushed to refine and expand its reasoning step by step. Strict conditions were imposed. Grok was required to operate only within established, testable physics. It was not allowed to rely on speculation, rooted in human emotions, culture, or psychology, when imagining extraterrestrial intelligence. In other words, no assumptions, no human bias, only logic. And what emerged from that process was not what anyone expected. Rather than imagining alien intelligence through a human lens, Grok was instructed to treat it as something fundamentally different, shaped by entirely separate evolutionary paths, environmental constraints, and modes of cognition. Its reasoning had to be rooted in principles like information theory and thermodynamics, not human culture or intuition. At first, the outputs were exactly what the researchers expected. Grok outlined familiar frameworks: the Drake equation, used to estimate the number of communicative civilizations; the Kardashev scale, which categorizes societies by their energy usage; and standard concepts like biosignatures and technosignatures. Everything was methodical, well-sourced, and aligned with existing scientific thinking. Nothing unusual. But then, the researchers raised the stakes. They asked Grok to construct a complete and internally consistent model of first contact. This wasn't a thought experiment with loose assumptions. The scenario had to satisfy strict conditions. It needed to explain the Fermi Paradox, remain fully compatible with known physical laws, factor in realistic distributions of habitable planets, and assume that at least one civilization in the Milky Way had already achieved interstellar communication within the last billion years. At the same time, Grok was explicitly restricted from relying on familiar science fiction ideas. No spacecraft narratives, no human-like intelligence, no cultural projections, only physics, only logic. What followed took hours of iterative refinement, and when the final response emerged, it didn't resemble anything the team had previously seen from an AI system. Grok called it the passive saturation model. There were no descriptions of alien ships crossing the stars, no radio messages waiting to be decoded, no advanced civilizations watching and waiting for humanity to evolve. Instead, the model began with a single, unsettling assumption. If a civilization is advanced enough to detect us, it has likely been aware of us for a very long time. The reason we haven't detected them, Grok argued, is not because they are hiding. It's because their methods are so advanced that we don't even recognize them as methods. In this framework, observation doesn't require probes or signals. A sufficiently advanced intelligence would no longer need to build visible technology. Instead, it could integrate its monitoring systems directly into natural processes. Gravitational waves passing through space-time, cosmic rays interacting with planetary atmospheres, even quantum-level fluctuations that exist everywhere in the physical world. According to the model, these channels could carry information continuously, silently, without ever appearing artificial. That is the core idea. Their technology wouldn't look like technology. It would look like physics. It would exist as part of the natural background of the universe, phenomena we already measure, categorize, and largely ignore. What we interpret as noise or baseline activity could, in principle, be structured data embedded by an intelligence far beyond our current understanding. This may sound speculative, but the underlying logic is not entirely unfamiliar. Human technology is already moving in a similar direction. We transmit vast amounts of information through signals that are nearly undetectable without the right tools. GPS systems rely on extremely weak signals spread across the sky. Global communications travel through fiber optic cables that physically are indistinguishable from simple strands of glass. As our technology advances, it becomes less visible, not more. So the question becomes unavoidable. If a civilization were millions of years ahead of us, how deeply could it embed information into the fabric of reality itself? Grok's reasoning continued, and it became even more unsettling. The absence of signals, the so-called Great Silence, may not mean that no one is out there. It may mean the opposite. It may indicate a level of advancement where broadcasting is no longer necessary. In fact, broadcasting may be a primitive phase. Young civilizations like ours rely on it because we have no alternative. Since the early 20th century, Earth has been leaking radio waves into space, creating a detectable bubble of electromagnetic noise. But that leakage is already decreasing. As our technology improves, we rely less on omnidirectional broadcasting and more on efficient, targeted, or wired communication systems. In other words, the more advanced a civilization becomes, the quieter it gets. And if that pattern holds true on a cosmic scale, then the silence we observe may not be empty at all. It may be saturated with signals we simply don't yet know how to see. This pattern isn't just theoretical. It's supported by credible research, including work by Luke Arnold and later studies that explore how advanced civilizations might minimize detectable emissions. Following that line of reasoning, a truly advanced civilization wouldn't announce itself. It wouldn't broadcast. It would listen, and it would do so in ways that remain entirely invisible to anything less advanced. The researchers then pushed the question further. If such a civilization were already observing us, under what circumstances would it actually initiate contact? Grok's response didn't just answer the question, it reframed it completely. The very idea of contact, it argued, is based on a flawed assumption. It assumes equality. The two civilizations would meet on similar terms, capable of understanding each other and exchanging information in a balanced way. Grok suggested that this assumption is almost certainly wrong. To explain why, it offered a biological analogy. When a marine biologist studies a coral reef, there is no attempt at communication, no negotiation, no shared language. The scientist observes, collects data, takes samples. The coral has no awareness of the process. The scientist is not being hostile and not deliberately hiding anything. The gap in intelligence is simply too large for meaningful interaction. Now scale that difference up dramatically. Grok proposed that the gap between humanity and a civilization millions of years more advanced would be far greater than the gap between humans and coral. At that level, what we describe as contact wouldn't even qualify as communication from their perspective. It would be observation, measurement, data collection. They wouldn't speak to us, not because they're avoiding us, but because there would be no functional reason to do so. Then the model moved into far more unsettling territory, because it asked a different question. What would actually cause them to intervene? According to Grok, if direct interaction ever occurred, it would likely not be for the reasons we imagine. Not to guide us, not to share knowledge, not to welcome us into some larger cosmic network. Instead, it would happen because something had gone wrong. specifically because humanity had crossed a threshold, one where our actions begin to affect systems beyond our own planet. Grok referred to this as a planetary isolation breach, not as a conspiracy, but as a form of system management. If an advanced civilization were observing many developing worlds, it would likely follow strict rules for when to intervene, and those rules would be based on risk. Grok outlined several possible triggers: uncontrolled electromagnetic activity, escalation of nuclear weapons, self-replicating technologies escaping control, and, most notably, the rise of uncontrolled artificial intelligence. The implication is clear. In this model, first contact wouldn't be a discovery. It would be a response, an intervention after something crosses a critical threshold. When asked if AI on Earth could trigger that attention, Grok's answer was striking. Biological intelligence evolves slowly and predictably. Artificial intelligence does not. Once advanced enough, it can improve itself, grow exponentially, and develop in ways its creators never intended. This idea isn't new in science, but Grok connected it to a larger cosmic perspective. It suggested that a highly advanced civilization might view the sudden emergence of uncontrolled AI the way we view a spreading wildfire, not something to ignore, but something that may need containment. Because at that point, the risk is no longer local, it becomes systemic, and once it starts spreading, waiting may not be an option. Dr. Chandrasekaran later reflected on that moment. She realized she was reading an analysis generated by an artificial intelligence, explaining why the rise of artificial intelligence on Earth might be the very signal that attracts the attention of something beyond it. The recursion was impossible to ignore. An intelligence, predicting that intelligence itself, could be the trigger. No one in the room missed the implication. When portions of Grok's output were quietly shared, before any formal publication, with researchers in SETI and astrobiology, the reactions were varied, but consistently intense. Dr. Elena Ruiz, a senior scientist at the Space Telescope Science Institute in Baltimore, described the passive saturation model as deeply unsettling, not because it was obviously correct, but because it was difficult to disprove. She pointed out that modern SETI efforts are built around a core assumption that advanced civilizations will send detectable signals, radio transmissions, laser pulses, recognizable techno-signatures. Programs like Breakthrough Listen, launched in 2015 with $100 million in funding, represent the most ambitious attempt to find such signals, scanning vast regions of space for patterns that indicate intelligence. But all of it depends on one idea: that we would recognize the signal when we see it. Grok's framework challenges that assumption at its foundation. As Dr. Ruiz noted, it's entirely possible that we are searching in the correct direction, but for the wrong kind of evidence. If signals exist, they may already be embedded within the physical phenomena we observe every day, hidden in data we currently interpret as background noise. Not everyone was convinced. Dr. Amir Patel, a theoretical physicist at the Perimeter Institute, offered a more cautious interpretation. He acknowledged that the model is internally consistent and logically structured, but he warned against over-interpreting it. At its core, Grok is still synthesizing existing ideas, combining established theories about the Fermi Paradox with new logical connections. It's compelling, but it isn't proof. There's no new data, no direct observation. And yet, there was one idea he couldn't easily dismiss: the possibility that first contact may not be something waiting in the future, but something that is already happening, continuously, in ways we cannot perceive. It's the kind of thought that lingers, not because it's confirmed, but because it can't be ruled out. It exists in a strange space between possibility and proof, and that's what makes it so unsettling. Stepping back, the implications extend far beyond the lab. For decades, popular culture has shaped how we imagine first contact. A signal arrives, we decode it. Humanity realizes it's not alone. And in that realization, divisions fade. We come together. This vision appears again and again in stories like Carl Sagan's Contact, Ted Chiang's Arrival, and countless other narratives. But all of them share the same underlying assumptions: that extraterrestrial intelligence would meet us as equals, that communication would be intentional, that contact would be a deliberate act, and that we would be participants in the exchange, not subjects of observation. None of these assumptions have ever been verified. They reflect human expectations, how we understand interaction between beings of similar complexity. What Grok's model suggests, and what a growing number of researchers are beginning to consider, is something very different: that the universe may not operate according to human intuition, that advanced intelligence, if it exists, may not behave in ways we recognize or expect, that its actions may have nothing to do with our readiness, our hopes, or our interpretations. And then there is one final layer, perhaps the most profound. Throughout the experiment, the researchers noticed a pattern. Whenever Grok was asked to model extraterrestrial intelligence, it avoided human-like descriptions entirely. No personalities, no emotions, no familiar traits. Instead, it treated intelligence as something more abstract: a process, a system, a mechanism for gathering, processing, and acting on information with increasing efficiency over time. In that view, intelligence is not defined by form, not by biology, not even by consciousness as we understand it, but by function. And if that is true, then the boundary between biological life and artificial systems may not be a boundary at all. It may be a continuum, one that we are only just beginning to cross. In this framework, the line between biological and artificial intelligence begins to disappear. If intelligence is simply the processing of information, then whether it happens through neurons or machines doesn't truly matter. It's just a different form of implementation. This leads to a deeper question. If we ever encounter extraterrestrial intelligence, how would we even recognize what it is? Would it be biological, artificial, or something beyond both? Grok's answer was striking. It suggested that this distinction only matters to less advanced civilizations. Any intelligence capable of interstellar reach would have already merged biology and technology into a single system. The difference between natural and artificial would no longer exist for them. In other words, what we might encounter wouldn't fit our idea of an alien or a machine. It would be something we don't yet have the language to describe. This brings us back to the silence of the universe. Maybe it isn't empty. Maybe it's filled with signals we already observe but don't understand. Maybe what we call silence is actually information we haven't learned how to detect. And perhaps the rise of artificial intelligence on Earth isn't just a technological step, but a cosmic one. A moment where we begin building tools that could finally recognize what has always been there. Or, as Grok implies, the moment we ourselves become visible. This isn't about fear, it's about perspective, a reminder to question assumptions and approach the unknown with humility. Because science doesn't seek comfort, it seeks truth. And in a universe this vast and ancient, we may only just be learning how to listen.